Good morning, dear students. I welcome you all here in the online session started by School of Scholars Malkapur. Student, now we have completed the chapter number 4th of standard 8th maths, that is cubes and cube root. Today we are going to start with the another chapter number 5th, that is playing with numbers. What is there in this chapter? What does it suggest to us playing with a number? What does it mean? What type of games we are going to play with the numbers? So here student, some special properties of the numbers are there in the numerical values that we are going to learn and that we are going to see here in this chapter. Okay, one more thing, playing with the numbers means already we know many topics of the number. So now whatever we have been learning from the lower classes till now about the numbers, we are going to help up that all the things. So one more question comes in our mind, what we have learned about the numbers. So that only I will ask you, what we have learned till now about the numbers. We have discussed various types of numbers, properties of numbers. Okay, then by using it we have derived many concepts also. From first I will recall, at the beginning we have started knowing about the natural number, whole number, then we had discussed about the integer, fraction, rational number. In the whole number we also know that what type of numbers are said to be prime number, composite number, co-prime numbers, twin prime numbers, perfect number, isn't it? These all things we have discussed till now. One more, rational number. In the rational number also we have discussed the properties of a rational number. What type of numbers are said to be the rational number, that also we had discussed. In the previous two chapters, one more thing we have discussed, that is what type of numbers are said to be perfect square number, perfect cube numbers. Okay, now up to now whatever the types of numbers I have discussed with you, can we represent that all the numbers over on the number line? If I will draw a number line, okay, here on this number line I have drawn, you know very well, at the 0 all positive integer will get lying, and in the left hand side all the negative integers. So here 1, 2, 3, I will replace 4 infinitely. Here minus 1, minus 2, minus 3, minus 4, infinitely integers will be there in the LHS side. So in LHS and RHS integers are there. Now here if I ask you the question, can we mark here whole numbers? Yes, we can mark. Can we mark here natural number? Yes, we can mark. Okay, can we mark here integer? Already integers are there. So we can mark all the type of integer. Here we can mark the decimals also, fraction, rational, okay, perfect square numbers also we can represent. The cube root of any perfect cube, that also we can represent. The square root of any number, perfect square number, that also we can represent. So here whatever the numbers till now I have pronounced, that all I can mark over here on the number line. But what about this cube root of 3? Does there any cube root of this 3 exist, or square root of this 3 exist? Even cube root is also not there. Okay, in the 9th standard you will be introduced one method. Okay, by that we can represent this under root 3 over on the number line. Okay, so here, but basically I will, one more thing I will discuss here, clear here, that we have discussed now till now whatever the types of number we have been discussing from the lower classes, that and this type of number, okay, where we do not have an exact answer. Here we can find the square root of this number by approximate value, approximate square root of this root 3 we can discuss. So here now we are going to classify the numbers in two categories. Okay, whatever we have learned, all the type of numbers are basically comes in two categories. Okay, here we can name it like types of number, types of numbers. So there are basically two types of numbers. What are they? First is called as rational numbers, and another one is irrational numbers. Irrational numbers. So here rational numbers are the numbers which can represent in the form of p by q, and where q is not equal with 0, that we know. So here we can represent whole number, natural number, integer, fraction, okay, decimal fraction, all the types of number we can represent in the P by Q form. Therefore, one of the category is there of rational number and another irrational number, a number which can't be represented in the form of P by Q. That is what? Square root of 3. There the square root of 3 does not exist over there, so we cannot represent in the form of P by Q. So therefore these type of numbers are said to be irrational number. One more thing, according to the decimal expansion, you know very well there are three types of decimal expansion. One, terminating decimal expansion means where you will have a exact decimals in your answer. Suppose here if I am saying 3.73, here exact two decimals are there. Okay, now here see, if I will give a division 1 by 3, when you will divide this 1 by 3, you will have an answer 0.3333, infinite 3s are there, there is no ending. You will never receive a exact remainder. Okay, so here this terminating decimal expansion, this is non-terminating decimal expansion. Two type of decimal expansions are there, terminating and non-terminating. In non-terminating, one more type is there, recurring and non-recurring. Recurring means here one of the digit or a group of digit will get a repetition continuously. Here 3333 you will always have, infinitely 3s you will receive. So this is an example of non-terminating recurring decimal expansion. Non-terminating recurring decimal expansion, and another one is in which you will always have a different decimal expansion. Suppose if I am saying 0.273542139, always I am receiving another decimal expansion when I will perform the division. So this type of decimal expansion is said to be non-terminating, non-recurring. So if we do not have exact value of this, so can we represent it in a decimal, can we represent it in a rational form? No student, we can't represent it in a rational form. So this type of also numbers are also said to be irrational number. Okay, so in the 9th standard, in chapter number 1st, that is real numbers, you will have to discuss this topic once again. So in the basic you should have this knowledge that two types of numbers are there, rational and irrational. Okay, now what is the use of this chapter, this topic here in this chapter, that also you will come to know. Now here many concepts which we have learned in the lower classes that we will repeat here once again. Like one more thing, that divisibility rule. Now you will say, sir, in the 8th standard there is no need of divisibility test to us. We already know that what type of numbers are divisible by 3, 4, 5, 6, 8, 9, 10. Even you can define the divisibility of test of 72. What type of numbers are divisible by 72? I know very well. All the students are aware with the divisibility test, but here the formation will be different. Okay, and now we are going to see the 5th standard topic. See here, now you will get shocked. 5th standard topic in 8th standard, but that is useful here. Suppose student, here I have mentioned the number 3,56,228. Okay, this number is there. What you can do with this number? You can convert this number in international numeration. Okay, it is in Indian place value. Okay, then you can define the place value of each digit, face value of each digit. That is useful here. Now if I will ask you what is the place value of this 8, then you will simply say 8 multiplied by 1 is equal to 8. Face value of the digit multiplied by value of a place is equal to place value. Similarly, the place value of this 2 multiplied by 10, face value of the digit multiplied by value of place occupied by it, 2 10s are 20. You can define each digit place value. What is the place value of these 3? Face value multiplied by value of a place. At a lakh place it gets 10, so therefore multiply by 1 lakh. So that is 3 lakh. This is the place value of this. What is the use of this 5th standard concept here in this 8th standard? Okay, now here we come to know that one more thing, 3,56,228. If I ask you to represent this number in the expanded form, what you will say? 3 lakh plus 50,000 plus 6,000 plus 200 plus 20 plus 8. Okay, it is an expanded form of this. What does it indicate to us? Do you have any guess? What does it indicate? It indicates us that we can represent all the numerical form, all the numbers we can represent it in the expanded form like this. Means the number is equal with the addition of its place values. Number means the addition of its all the place value, all the digits. Okay, now here it was a number, that's why it was very useful and easy for me to indicate in the addition sum of its all place values. But if instead of a number, if I will take the alphabets, then how do I can represent? Okay, how do I can represent? See here, if I am saying A and B are the ones and tens place digits of the number, then represent the number. A and B are the ones and tens place digit of the number, represent number. B add a tens place and A it as a ones place. So most of the students will say that BA is a number. BA is a number. But student, in the algebraic expression we come to know that when you will take two alphabets together, it indicates us multiplication. It indicates us multiplication. Here A multiplied by B, that we cannot do. Can we say here 332 is a number? So here 3 multiplied by 2, 6, can we represent? No. So here if you want to indicate this number, you will have to take the help of its expanded form, place value addition form. So here BA means B at a tens place. The place value of this B will be 10 multiplied by B. Face value multiplied by value of a place, that is 10B. And the place value of A will be A multiplied by 1, that is A only. So it will be your 2-digit number according to the condition. A, B are the ones and tens place. A at a ones place and B at a tens place. So here it is your 2-digit number, expanded form. Got it? Similarly, if 3-digit is given to you, 3-digit, A, B and C are the ones, tens and hundreds places digit of the number. Ones, A, B and C are the ones, tens and hundred places digits of the number, then find the number. A is at a ones place, B at a tens place and C at a hundreds place. Then 100C plus 10B plus A. It is a 3-digit number. Got it? So now here, what is the use of this? Simple thing. There is one more question is there. Sir, you can explain it in one sentence only. I was able to define it in one sentence only and you would have catch it easily. But student, by using this simple concept, you will be asked a different and difficult examples. That seems difficult, but actually that are easy. By using these concepts, I'm going to ask you one question. Now see here. Now here I am going to write one question. See here. The sum of the digits of two-digit number is 9. Okay, two-digit number is there, and if you will do the addition of both the digit, the addition is 9. It is the first condition given in your question. Another condition, if we interchange the digits, the new number reduced by 63. If we will interchange the digit, the new number will be 63 less than original number. Okay, question is there, find the number. Okay, suppose here in an answer, before starting, see here 35 number is there. The expanded form is 30 plus 5. If I will interchange the digit, what will be the number? 53, and expanded form will be 50 plus 3. Similarly, instead of the number, if I will take the alphabet, my first number is 10a plus b. When I will interchange the digit, what I will receive? 10b plus a. This will be my new number when I will interchange the digit. Got it? By using this property, I am going to solve this example. Okay, here it is given that the sum of the digits of two-digit number is 9. Okay, whatever the digits are there, if we will do the addition is equal with 9. Second condition, if we interchange the digits, whatever the new number will form, that will be 63 less than the original number. Okay, it means simple thing comes in our mind, that the difference between original number and new number, it will be of 63. By using this, we will solve this example. We have to find the number, but if we don't know the digit, how we can find the number? At this stage, we don't know the digits, so here we will assume the digits. We will take the help of algebraic expression chart. Okay, let the digit at ones place b, a, and the digit at tens place b, b. These are the digits at ones and tens place. Okay, so therefore the original number is equal to 10b plus a at a ones place and b at a tens place. This is our original number. Now two conditions we have given. Follow the condition according to condition first. This is an example of 10 standard, that's why it is very important. According to condition first, we have given the sum of the digit is 9. A plus b is equal to 9. Okay, so therefore if I want to know the value of a, what I can say? A is equal with 9 minus b. I received here value of a. We will keep it at a statement first. We received value of a. Now according to condition second. According to condition second, what is the condition second? Condition second is there, if we interchange the digit, then by interchanging the digit, the new number will be, first number is, original number is 10b plus a, new number will be 10a plus b. Okay, new number is 10a plus b, but it is said that the new number will be 63 less than original number. It means the difference of original number and new number is 63. Okay, therefore the difference that we will mention original number is 10b plus a and new number is 10a plus b. The difference will be equal with 63. Now solve this. 10b plus a minus 10a, before the bracket minus sign is there, so inner bracket integer sign will get changed, that we know very well. Minus b is equal to 63. So 10b minus b 9b, okay, plus a and minus 10a. Unlike integer, operation subtraction bigger number sign. 9 minus 9